All Things DER podcast, brought to you by AEIC. My name is Dr. Elizabeth Cook. In this podcast, I dig in, define, and discuss where the new energy economy is heading with electric industry leaders and explore all the ways that distributed energy resources can modernize and improve our ever-evolving power grid. Thank you for joining us. In today's episode, I'm talking with Allison Bates Wannop, the Director of Legal and Regulatory Affairs at Voltus, Inc. We discuss communication difficulties and fundamental differences that arise among the transmission, distribution, and aggregator sectors within the power industry. From the proven success of the demand response system to the regulatory barriers that stifle entrepreneurial companies from developing beneficial new technologies, we have a lively conversation that eloquently depicts what collaborative synergy and cooperative work can do to enhance shared vision of a successful future as a whole. So with that, welcome. I'm going to tee you up here, but anything you want to add?
No, thank you for that great introduction. I'm really excited to be here. I mean, energy markets and DERs are literally one of my favorite topics in the world.
Right. And I feel like we are kindred spirits because we can both say that. So, I mean, one basic and easy one, but I think will be great for our audience is, what do aggregators do?
Well, fundamentally, aggregators just manage energy consumption and energy devices, which can be as small as your smart thermostat, so that together they can operate just like a traditional power plant. So that's fundamentally what an aggregator is doing. And so I think, as most of your listeners know, a distributed energy resource is simply something that is on the distribution system rather than the transmission system. But we like to think of these in terms of the four horsemen of DER. So energy efficiency, distributed generation, solar and wind on the distribution system, energy storage, and demand response. So demand response has the least intuitive name, but it is the DER that has been in the wholesale market for the longest amount of time. And that is simply turning things off rather than turning things on. So I think it's more intuitive to think of it as energy flexibility or load flexibility. What's interesting is that the market pays for this in exactly the same way as it pays for traditional generation. So a power plant that's 600 megawatts, we can have individual resources that are, as small as a kilowatt and aggregate those up to provide 100, 200 megawatts or more of load. We call this a negawatt, and we have resources that are maybe some of the 10 biggest power units on their system, maybe a large data center, and that can really help the grid just by turning it off. So when you start leveraging other technologies like energy storage, distributed generation all together, you can shift load, you can turn things off, you can turn them on, say pre-cool a home or preheat it when it is a high generation period. So that's in general what the idea is of just managing energy consumption, leveraging things like water heaters and smart thermostats to operate just like a traditional power plant.
So you said a whole lot, which is super exciting. And I wrote down the four horsemen analogy. And you kind of dug into the demand response aspect. And I think, that is the most tangible and concrete service or that an aggregator can provide. So I guess I just wanted to share from your perspective, demand response has really been around since I would say 1980s, 90s. And we've, as an industry, proved out that it is a powerful tool in regards to managing the grid. And another thing I like to do on this podcast is really break down terminology and language. So you said energy management, right? You're controlling thermostats and managing load. So would you agree that that also falls under the umbrella of said technology as a load management or a demand response management or a distributed energy resource management platform? Could you see those kind of all interacting in different forms together, but the same umbrella? Or am I thinking of that wrong?
So a distributed energy management software platform, a DERMS platform, I think of as a utility platform to manage distributed energy resources on its system, which we might integrate with to manage the resources that we are dispatching for participation in the wholesale market, or we might be doing it not through a DERMS platform.
Okay, so and I think it's helpful to just, I find myself in a lot of conversations with multiple entities across the industry of their definition of a DERMS is different. So just that one kind of technology, it's what you want it to be, and it's the use case that you're solving for. And where we've found, I guess, we see the DERMS as more of control of the actual assets of the grid, where you guys have a different platform managing just the energy. And I think I said this word now a couple of times, services. Would you say, like, what services can an aggregator provide? The demand response, and then I think you talked about all the others, right?
So before talking what aggregators do, I think it's always important to level set about the terminology, kind of as you and I were just discussing. So we're first of all just talking about aggregators enabling customers direct participation in the wholesale markets, which is distinct from either a utility running its own DER program, maybe managing batteries, or even an interruptible rate program, or hiring an aggregator to essentially be its program administrator. So again, we're talking about aggregators contracting with end use customers to enable their direct participation in the wholesale market. So just to talk briefly about wholesale markets work, to level set here, there are 9 North American wholesale markets, of which FERC regulates 6. All of those markets have an energy market and an ancillary services markets, and all have a resource adequacy construct, which ensures that there's enough generation on the system. So SPP in California have an LSE resource adequacy obligation at the load serving entity level. PJM, ISO New England and New York have a capacity market. And then there's MISO, which, as well as Ontario, is somewhere in between. There's an LSC obligation, and then 5 to 10% of capacity procured through what's called a residual capacity auction. And so those are the market constructs within where we're operating. So historically, as I think you touched on earlier, the biggest DER wholesale market participation has been demand response, doing what's called capacity programs. So this is where a resource registers. If you're in PJM or New England, this capacity auction happens 3 years ahead of time. And the resource is awarded capacity, it receives a base payment, and it might be called on, say, 1 to 2 times a year in a real emergency. This is the panic button, these traditional capacity programs. Okay. You're seeing more DERs do this now, not just demand response, residential, solar, and storage, with companies like Sunrun and Sonova doing this, and ISO New England's capacity auction. So this capacity product is broadening. More recently, a variety of DERs are doing ancillary services, which are typically frequency response, spinning reserves, and non-spinning reserves. In PJM, companies like Mosaic have been aggregating hot water heaters for frequency response for years. Voltus, my company's specialty, is operating reserves, both spinning and non-spinning, using load. So these are 10-minute events, maybe 6 to 8 times a month, but are still providing that service by turning things on. So in contrast to the panic button of capacity programs, ancillary services are going to be providing regular grid balancing using DERs. And here, a resource is paid a standby payment to be available, and an energy payment if they are actually dispatched. These are often, the terminology of the virtual battery. So most people don't often know that DERs are already doing this now in this space. And so I think that's really important to know that that use case is out there. I've talked to regulators who are stunned that we've developed the technical integrations and the technology to be able to provide operating reserves, because they are fast response events. You have to respond within, say, 10 minutes. So one thing I think it's important to remember when it's talking about ancillary services is that this is really complementary to what a customer might already be doing under a retail rate, like an interruptible rate or a net metering rate, that this is something that is completely additive and distinct and non-duplicative for a customer doing operating reserves and to their retail rate. And then energy market participation is just getting paid by the energy market for injecting or reducing load. And that would, be paid just like generation at the LMP. And this is where many DERs are planning to contribute batteries and distributed generation on the distribution system being paid for their injections and being paid LMP for performance.
So that is quite a lot. And so if you think when we're dealing with a grid that ultimately it's approximately 140 years old in North America, is probably one of your oldest grids, I get to oversee over here in Pittsburgh, Pennsylvania. It ultimately was built to serve from a bulk power plant, large transmission down into the customer one way. Then the energy markets were formed as we started connecting our systems across state borders, and our grid ultimately got intertied into three large machines, the Eastern, Western, and Texas. And now there's an energy market in itself, which I think from an operation planning perspective, we lose touch with, right? Like there's an energy market, and then there's actual, like, how do the electrons flow? Where are they flowing? And how do we ensure safe, reliable, and affordable power from a general perspective? And so all of that you shared, is great information and knowledge, because, these devices are no longer just a load where we're just serving electrons to ensure that the lights come on. They now can start facilitating under various, realms, entities, even though it's fundamentally the same. So that's just it's a hard gap, I think, to communicate across. Sometimes it feels like oceans, right? Like, because you're doing it and it's working, but like it's such a large grid, really, just to get everyone on the same page, I think is really why we're here today. So thank you for sharing all of that. And I definitely am gonna, in our show notes, help summarize those poignant remarks that you made.
Well, I think that's, the whole point, that it is an increasingly decentralized grid, whether we want it to be or not. These DERs are coming. And in addition to needing more or having more decentralized resources, we need to solve more decentralized problems. In California, they're discussing an imbalance reserve product to add as a new ancillary service, because they're seeing grid imbalances that are short, about a megawatt, and they're very localized. And so it is this intersection of reliability and the energy markets trying to address these issues together.
So I guess I just wanted to tee up, the how. So how does an aggregate dispatch the resource? Like, create some tangibility around that for our audience?
Yeah, so whereas 10 years ago, maybe 10% of resources could be automatically dispatched, now with the cellular network and the hardware technology that we've developed, companies might have 60% of their resources automatically dispatched and curtailed, or have their consumption changed. So it takes a lot of work to develop that technology to automatically dispatch those resources, but it can also still be a very human intensive endeavor. For that remaining 40%, it can be knowing people to call to go and actually physically turn things off. And we have, anecdotes about employees like jumping off planes because all of a sudden a dispatch came through and they wanted to make sure that it executed. And so we man a 24/7 dispatch center, and it's a lot of work. And it's something to think of, if you are a utility, is that, or if you're a regulator, is that what you want your utilities to be doing in, a big grid stress condition?
So I kind of like bringing around the grid was made for one way. It was centralized. Now we're decentralizing it. That you kind of explained the how. And I think what resonates with me is, and kind of my second passion, is understanding human behavior. And we are hardwired to resist change, right? So it's okay to acknowledge that. And it means that we're kind of all alike. However, so is the grid, right? It's wired to not like really this change, but it's happening, and it's happening dynamically. And what I'm hearing you say is, the companies and the capabilities and the innovation has really arrived at the demand side to really change the way that the grid was ultimately wired. So it's like a resistance that we all are feeling, and it's true. And it's how do we come to the table with this win-win-win altruistic mentality. And I think it's just, again, it's bringing the awareness and these fundamental things that are already happening, right? So how do we understand them? And then how do we move forward together? So anyway, I got on my soapbox. So.
No, I mean, this is why I feel like you and I connect, is that I would say that 2222 is really about removing the human-made barriers to the participation of these resources, so that we're just then left with the technological barriers. A rule that says this type of technology cannot participate in this type of service because it was written 10 years ago when that technology could not provide that service is a problem. We should say what the service is, what your technical capabilities are to meet it, so that then the technology can catch up to provide that service, because the private market has an incentive to develop that technology to catch up to that service.
And you read my mind, because I was going to ask, how do you see the opportunity, for 2022? So, which ironically, can we say the date we're speaking is 2222?
I was thinking of that too, yes.
So I guess, does that, the opportunity for 2222?
Exactly. I think that 2222 is about removing the market barriers for participation that are holding back resources from providing services that they are technically capable of providing. And like you just said, we have these DERs, we have this distribution system, we have this transmission system, and we have these wholesale markets. And we need to make all of these things work together and realize that there are cost benefits and reliability benefits of doing that. And that lets everybody kind of do what is their best task. It lets the utility focus on reliability, and it lets private companies like aggregators develop technologies that are very time intensive, that fail a lot, that can be very hard to develop, so that they can, obtain those revenues in the wholesale market.
I agree. And I feel, from a planner's background, right? Like when we do not understand something, we are fearful of it. And then also we're also hardwired to change. So understanding the increasingly made innovation at our fingertips from the other side is really important, because as we're facing this very dynamic, some may call fourth industrial revolution, these technologies are arriving. We have a grid that has existed. How do we plan? And especially we've been planning and really driving, we spoke about this in a prior podcast, our own commodity downwards, right? Selling energy efficiency, knowing that the grid can only handle certain capacity. However, I have to say, and I'll say a couple of times, is the grid can handle this increased electrification of vehicles, as long as we're planning and getting the information and using the tools that are available to us. And one of the tools is using this innovation that you're kind of describing here today to really help facilitate this new technology. So I think it's very exciting. And I hopefully, we're planting some seeds and knowledge to really kind of take and really dig in further. So I guess I just want to kind of say, what is a fundamental takeaway that you want people to have from this discussion?
I think that the biggest one is what I've already touched on, is that we just have to get to the point where we remove the human barriers to our energy transition, so that we're just can focus on the technological barriers. For example, market rules that bar technically capable smaller resources just because they are drafted contemplating generators. And this is an example of where we talk about, you skate to where the puck will be, not where it is. So we don't want these rules hardwired based on what the technologies can do now as we sit here today on February 2nd of 2022. We want them to be drafted with what the needs are, so that we can develop technologies to do that, even though I think that those technologies are already far more capable than people might appreciate. I mean, to emphasize, I talk to people all the time who live and breathe energy markets and how this market has been designed to work, and are surprised at what our technologies are capable of doing. So with that context, the takeaways are that DERs are coming. It takes a lot of work to optimize them and to make sure that they can be used to their fullest potential. It is a lot of work. A lot of companies have failed trying to develop the Internet of Things technologies that it takes to develop and operate DERs. And so I think because of all of that, and because of climate change, we are all in this together. Let the private market do what the private market does, which is develop new technologies and figure out business models for those to work. These are complementary and additive services to utility rates often, and the utilities can then focus on their obligation to serve and to provide reliable electric service. And I do really believe that with our distinct and complementary interests, we can all work together for the benefits of grid reliability, for the benefits of ratepayers, and for the benefit of the climate. So Elizabeth, I know that this is your podcast, but I agree with you that we all need to appreciate each other's perspectives. And so if you wouldn't mind, I would love to ask you the question of what you would want aggregators to know, how somebody looking at this from a planning perspective with the background of an electrical engineer, what you think I should know.
Well, that's a great question. I could talk a while for it. So, I think a lot of my passion has come from, I was a consultant, kind of developing models, running studies, and really driving educational awareness within utilities of like all different phenomena. And when I came into the utility space and working within, I was sitting as a system planner, and I found, we have this grid and it already has a certain amount of capacity, and it has been programmed to take the electrons in the path that has been built for. And quite frankly, the rudimentary backbone of the grid has been around for 80 plus years in most grids, right? So as a planner, knowing that our grid is already being utilized a certain way, we are only allowed to have so much think about, we're a regulated company. So any type of new challenge or new need for innovation is really kind of one against the grain of how a utility is incentivized in general. But you're sitting as a planner and you're seeing all of this new technology coming on board. It comes in slowly, so it doesn't really seem like a big deal. Like, oh, you got a couple solar, then you got 100, then you got 1,000. And it's like, okay, how do you send up the red flags to the regulators and the leaders to say this is a burden? Right? A burden to, one, we don't have the tools yet. We haven't been incentivized to be innovative, to understand and start learning how those electron flows changing direction and changing rapidly, that we have that ability to control or manage or to do it safely for all. So, as a planner, now you have all of this data analytics at your fingertips, but you don't have access to the data because that is an innovation bucket. You now have this impeding extreme weather conditions kind of coming across all elements. For us, it's, flooding and landslides, but for other utilities, it's, fires. So your focus is very different, right? You're trying to keep the grid up, but also knowing that you have all of this new affordable technology and innovation happening all around you. So you're kind of like racing against the clock, and you're trying to figure out where can you assign your time and focus and ensure that the regulators and our ratepayers and our ownership all understand those very dynamic variables to show up at the table with a set of projects to be able to execute on, while you're trying to reduce energy burden, right? You're trying to build out resiliency and kind of embrace this whole new clean energy technology at the edge. So I know that's a lot, but it's like all of your markets, like that was a lot. Like, how do we just get comfortable with the significant unknowns that the seat of the utilities are seeking, because our focus has been, reliable. Like if our lights go out, who's the first person that gets called and who becomes very angry, right? So then, well, to make sure your lights never go out, it's going to create a certain momentum in what we focus on. Then also seeing this new way of doing things is that resistance of change. So I don't think it's positive, like what do you assume positive intent, but it's very complicated. So I think from your side looking in is, how can we drive and support and incentivize utility to show up with that innovation hat? And I think a lot of utilities have been taking that, but it's more of a struggle being within the business model that we're in versus that entrepreneurial innovation. So how do we kind of match that or really understand those hardships and then do it together? If that makes sense.
Or, delegate that entrepreneurialism if that's what would work.
Well, and then I guess the idea is, because we have to know what's happening out there, there's a burden that becomes on the planners and the operators to manage and just have that visibility. So we also have to have that technology just to know how to turn on and off and program the certain devices from a feeder and substation level. And I think that's where we get a little bit nervous of how do we have a safe grid without not knowing. So therefore we want to know what's connected. So that we can manage on a day-to-day. Because I think another misconception is the transmission grid is pretty steady, right? Like if there is a breaker that operates, there is a significant amount of paperwork, let's just say unplanned operation, significant amount of paperwork from a standards obligation to say why that happened and how you're never going to have it happen again, because those transmission lines are expected to stay in. But from a distribution grid, it's very networked, it's meshed, and then also in some areas very rural. So how every individual distribution grid is ran and operated and planned is dynamically different from uni to co-op to EDC to state. So know that those lines and breakers are switching multiple times per day based on motor vehicle accidents, vegetation, storms, like your lights go out because things are actually like touched and switched on and off. So that's, I think, that another concern is like how the distribution grid is operated is much more dynamic and changing than say a transmission grid, which we're more used to from like a demand response that we talked about. That's at like a bulk level, like you can control it from chunky loads. But now we're getting into like the granular parts of the grid, which then you get a little bit nervous about ensuring that things are being turned off appropriately or not being backfed. And you can transfer the load like you always did before, knowing that everything will be safe when you do that. So that's kind of another hindrance, right? So that visibility is kind of a need.
Yes, the coordination aspect between transmission, distribution, and aggregator is one of the meatiest parts of this conversation, and really where we're looking to develop solutions that work for everyone. So I think that piece about the distribution system being different from the transmission system is really helpful.
Well, I just wanted to thank you for that enlightening conversation. I look forward to reviewing it and really kind of absorbing that information and taking it into my own engagement. And then also thank you, listeners. I know there's lots of podcasts out there and there's a ton of information being shared. And I think one of the key elements to everything that we just talked about is identifying what our differences are, understanding both sides of the table, 3 sides of the table, in my opinion. I think there's probably 9 sides of the table in this discussion, and really taking that step forward. And ultimately, the grid is here. It's the lifeline and serves society. It's the electrons that we light up our lives with, but we have to work together to transform that for the grid of tomorrow, which is yet to be defined. And I look forward to doing with people like you, Allison. So with that, thank you. That's a wrap for this week's episode of All Things DER. Thanks for tuning in. I hope today's conversation got you thinking about new and creative ways to improve our power grid. Be sure to subscribe to our YouTube channel to be the first to hear new episodes. This podcast is brought to you by AEIC, the place where operations leaders come together to share knowledge and provide guidance to the electric utility industry. We'll be back with a new episode next week. Until then, keep powering on.